Hello, today we're going to talk about the AlexNet and VGGNet. First, let's talk about what is AlexNet. AlexNet is a convolutional neural network named after Alex Krivhevsky. It is built for ImageNet classification challenges. It is the first CNN that outperformed non-deep learning-based models on the ImageNet classification challenges. The structure of AlexNet is shown on the diagram. It has several features. First, it uses ReLU as activation function. This method zeroes out all the negative values and keeps the positive values. This is a nonlinearity that has no saturation with region, which makes training significantly faster than other saturating nonlinearities. Since the network was proposed in 2012, the computational power of the graphic card they used, GTX 580, only has 3 GB of memory. So they parallelized the computation and spread the network into 2 columns. This structure enables the network to give better performance and faster training time. Local response normalization scheme is also used to aid generalization. The expression is shown on the slides. Since you use ReLU as activation function, there's no worry of saturating the nonlinearity. Normalization will be applied after ReLU. This is proven to be effective on increasing the performance of the network. Pooling layers are also added to the network to summarize the outputs of neighboring groups of neurons in the same kernel map. Since the patch size of this pooling method is said to be greater than the stride size, the pooling process is overlapped. This method not only improves the performance, but also helps to prevent overfitting. On the diagram, you can see that this AlexNet has 8 layers. The first 5 layers are convolutional layers, and the last 3 layers are fully connected layers. The ReLU nonlinearity will be applied after every single layer. Response normalization will be done after the first 2 layers, and max pooling will follow layer 1, 2, and 5. Since the network is divided into 2 columns to enable 2 GPUs running simultaneously, the GPUs will communicate on the third convolutional layer and both fully connected layers. And finally, the output of the network will be fed to a 1000-way softmax, which contains 1000 labels for image classification. Each label will have a likelihood predicted by the network. If your input is a cat image, the label for cat will have higher probability if your model is properly trained. This groundbreaking network has inspired many. One of the more advanced networks came in later is VGGNet. It is named after a visual geometry group in University of Oxford. In 2014, they proposed a network called Very Deep Convolutional Network for large-scale image recognition. Just like its name, it is really deep. It can have 16 layers and 19 layers, which is really deep at that time, before ResNet comes out. VGGNet also has 3x3 kernel for convolutional layers. Instead of having single large receptive field, VGGNet stacks multiple small filters to learn more complex features. The creators also distrust local response normalization, as they think it will lead to increase of memory consumption without improving the performance. And because VGGNet is too deep, bad initialization can stall learning due to the instability of gradient in deep nets. The network training starts with shallow configurations, then go to deep once initialized. The structures for VGGNet with different depth are shown on the right-hand side. For VGG16, there will be a pooling layer following every 2 convolution layers for the first 6 layers. Then, output of every 3rd layer for the following 6 convolution layers will be pooled. 3 fully connected layers are placed before the softmax layer, which map the probability distribution for the 1000 labels. For VGG19, an actual convolution layer is placed before each pooling layer except the first two pooling layers. The network ranked second in the ImageNet classification challenge by the time it was proposed. Although both VGGNet and AlexNet are mostly obsolete now, their pioneering work shaped the whole industry of CNN-based image classification. Thank you.